Hey, Dave here from Tab and Slot. Today we're going to take a look at building one of our CertiFlat weld table kits, okay? So this is what's included in the kit. You've got 4 leg posts, you've got 2 long cross braces, 2 short cross braces. Of course, the caster set, we send you 4 nuts, 4 caster plates, and we even give you a caster wrench because the caster's got an 8-sided nut on it. And then of course the top, which is in this case a 2-foot by 3-foot pro kit, which is 3/16. They all go together the same regardless of the size or the thickness. And the webbing that goes underneath the table to force the table flat. And this is really what makes our tables substantially stronger and quite a bit more unique than everything else out there on the market, okay? Before we get started, you're going to need a few things. You're going to need a couple of boards or some scrap sticks of tubing. I'll show you why. It's nice to have 6 to a dozen C-clamps, good heavy-duty C-clamps, not completely required, and you're going to need some miscellaneous nuts and bolts and either some scraps of tubing or some little chunks of wood or 2x4 that you can drill some holes in. I'll show you why in just a minute. Before we get started, I just want to talk about weld tables, quality, and flatness real quick. We get an awful lot of questions from people asking us, can you Blanchard grind a table for me? I need something that's got to be flat to plus or minus 3 thousandths. No, you don't. There's a difference between a welding table and a granite inspection table, okay? Now, our welding tables are without a doubt the flattest welding table you can get your hands on, made from sheet metal, okay? Obviously, if you want to invest in an acorn cast table that's ground, it may be flatter over a long span. It might not be either, okay? The reality is, nothing you're going to put a weld bead on is going to stay flat to 5/6 thousandths. It never is. If it stays flat to 15 thousandths, depending on how long it is, you're pretty lucky, and you're probably never going to see that unless you go looking for it with straight edges, okay? We spend an awful lot of time engineering weld fixtures for many of the OEMs, and we know how to control a weld pull. The way you do that is with very expensive tooling that can adjust and compensate and correct a weld pull, all right? This is going to be the best welding table you can get without going to a ground cast piece. Don't spend too much time worrying about feeler gauge flatness here. You're going to be building a quality tool that you can be proud of that's going to serve the purpose for virtually anything you could possibly do on a table of this size. And it's going to be substantially flatter and stronger than any other table this size. So, like I said, you can spend all that time with the feeler gauges. I'm not trying to talk you out of that, but put the pride into building a quality tool that lasts a lifetime. Don't worry about the 5 thousandths here, because you're going to be the only person that knows about that, and it's never going to matter. So, let's get started. I'm going to move some of the stuff out of the way, grab a couple of 2x4s, and I'll be right back, and we'll get moving on the top first. All right, so I've got the top up on a couple of 2x4s here, or actually 4x4s. We're actually going to build the top upside down, okay? So the way these work is the ribs that need to go in first, these little tabs right here, go into the slots on the table. So those are going to be down in this case because we're upside down, which means that the first ribs we have to put in are the ones with the slots up, because the other ribs are going to sit on top of those, okay? So I've got a couple of them in, just going to stick these in. Now we engineer these to be pretty snug as they're going in here, and you'll see that this is damn near a machined fit, okay? Now, if you get one that doesn't go in by hand, stop, take a look at it, and make sure it's not a problem. If it's just a snug fit, then it's not a problem. If there's a burr or something in there, then you may want to take a file to it. Now, I didn't even check these for burrs. I gave them a quick look. I saw that there was no laser slag on any of them, and I'm going to put it together like that. And we may or may not find a problem, and I'm kind of hoping we do so I can illustrate that point. But very frankly, these things are so precise coming off the laser that the fit is outstanding, and there's very rarely a burr or a problem. So I've got the short ones in that go across. These are the ones that have the notches up. Now we're going to plug in the long pieces. Now, as we get into this, you know, now we're going through, we have 5 tabs in the tabletop, right? You can't see from over there, but there's 5 tabs on the tabletop. Plus we have the alignment, you know, where all these things cross. So if this went in by hand, which it did, that's pretty cool, right? So you can see there's no wiggle here, very little if any, and this whole thing goes together. Now, I do have a hammer over here. I brought a dead blow hammer in case I needed one. I may or may not as I put the other 2 ribs in, but the goal with the hammer is just to get these into place, okay? We're gonna let our clamping process pull everything flat. So I'm gonna put these other 2 in, and then we'll start clamping this up. Okay, so again, light taps with the hammer to seat everything. I got one high corner here. I think I'm going to pop this one back out and see if I can find the problem. Okay, now the problem will be pretty obvious if I look at my tabs. I can see that this one has a little gouge on it. That may have been a burr right there. It may have been a burr right on this slot. So I'm going to take a look at that. I'm going to take a little file, correct that, put this back in. I'll be right back. Okay, so I just grabbed a file here. I can see there's a little burr right there. It's not actually a burr because I'm going to be able to just kind of bust it out of there instead of filing it out of there. It was just on the edge. And since I've kicked up a little burr here, I'm just going to file that flat. I could have taken a grinder to that. It really wouldn't have mattered too much. And just because I know there was an interference there in the past, I'm going to flip this rib over and put it back in. And that's a perfect fit. That's exactly what we're looking for at this stage. I'm going to grab some clamps, and I'll be right back. Alright, I shut the camera off there because I know you guys don't want to stand there and watch me unscrew clamps. And I keep all my clamps clamped to the edge of the table, so I don't unscrew all of them. So what you're going to do now is take as many clamps as you can and work your way around the perimeter of this, okay? I typically start in the corner. Here, I'll start with this one up front. And what I do is I position the pad of the clamp directly over the cross where those 2 pieces of sheet metal meet, okay? Grab another clamp here, get one on here. Alright, easier to move myself than the camera. And you don't have to have spendy clamps or anything fancy here, you know? If you don't have any clamps, now might be a great time to run to the Home Depot and buy a whole bunch. We'll even let you blame it on us if somebody goes snooping around your credit card bill. So we'll get all the clamps on here and I'll be right back. Okay, so I've got clamps on every joint I can get to without a long clamp. Now, I have a couple, but they're pretty flimsy. I don't have clamps that reach to the center, right? And we definitely want to clamp that. If you look right here, you can see the air gap under that plate, right? And we got to get rid of that. So what we do is we grab some scraps or whatever that have holes in it and some 3/8 nuts and bolts. And you could actually do this, you know, if you only had 3 clamps, you could do this. And, you know, you're not wrecking any nuts and bolts or anything, so it'd still be good. So what we're going to do here is we're going to put these up through the bottom. Get my fat arm under there. Do that. All right. We'll put those up through the bottom and just put them through some of these holes here. Let's see, let's go that one and that one. That'll work. And get a couple of nuts. And just put the nuts on here, okay? So we're gonna do that at both of these spots here, and I'll get a close-up of that. And then we're gonna do our final inspection, and we're probably gonna be good to weld. So I will stop the video, put the other one in the middle here, and be right back with you, and we'll start welding. All right, so I've gone ahead, and like I said, I've just taken 2 pieces of scrap that we had laying around with some nuts and bolts up through the underside and stuck this flat. And this is gonna sound a little strange, but you can tell when it's flat because it stops making noise. As you're pulling this together, you can hear it kind of push the dust out of the way and stuff, and when it stops making noise, it's done moving. And a quick light gap check, if you hold a flashlight down here and look for light gaps, verifies that. Now, we talked earlier about not getting, let's call it weird about flatness, but you're still looking to build a quality tool, right? So at this stage in the game, what I'm looking to do is adjust this, okay? So I'm gonna grab a straight edge. I know for a fact this ruler is damn flat. I've checked it on the table of the mill. And I'm gonna go across it both directions. Now, I can tell that this table's just a little bit low. Well, high because it's upside down, right? But just a little bit low in the middle there. And if I come this way, it's just about perfect, okay? So the way you can tell that is because when the table's like this, the straight edge touches in the middle and it scrapes on the outside. When the table's like this, it touches on the outside and the middle moves free, right? I can flex this ruler and I can feel when it starts to scrape. Going this way, the table's just a little bit of this, okay? So I need to flatten this out this way and flatten this out this way. So I'm going to hit it once with the hammer here, once with the hammer here, and I'm going to check it again. Okay. Now, this is absolutely perfect. I can feel it scrape on all 3 points. And it is absolutely spot on perfect there. And spot on perfect there. So, we're going to start welding. I'm going to get you some close-up shots of this stuff, and then we'll start welding this thing up. Be right back. Okay, so we've checked, we've got everything clamped, we've checked it for flatness, we're happy with where everything's sitting. I'm not even going to bother tack welding any of this, okay? The reason for that is because the clamps are doing their job. We don't want anything to move, right? So how do we keep that from moving? Let's talk about weld pull for a second. If I put a weld bead here, this is going to curl up like this, okay? Because that bead is always going to shrink and it's going to pull. So if I put a bead down here in the V groove, as that bead cools, it does this. So we don't want to put any unnecessary heat into our table. And the reason our tables stay flat is because the top is only connected to the skeleton through the tabs on the other side of the table. And when we flip this over to weld the top on, you'll see that. So our goal here is to not weld the ribs to the top at all. Right now the top and the ribs are all kind of holding each other flat, right? Because we've set those. So what we're going to do is we're actually just going to weld on the ribs here. Okay, we're going to weld the ribs together because if they pull a little like this, it's less apt to affect our flatness than if we weld them to the table. And now we might be pulling the table. Okay, I hope that makes sense. So what I'm going to do is I'm going to weld one weld about 3/4 of an inch long downhill on each one of these intersections. And I'm going to do it symmetrically. So it doesn't really matter where you start, but if I'm on the outside over here, then I want to be on the outside over here. And that follows suit all the way around. Don't start piling weld on. The idea is to glue this together and make it solid while putting as little heat to it as possible. Okay, so I'm set up with a MIG welder. I'm running 030 wire. I'm on a 250 amp machine set at, roughly 2/3 of the way up. So what does that make it? I don't even know. You figure it out. You do the math. And what I'm going to do is I'm just going to go around and I'm going to put that 1 3/4 inch weld at each intersection. So I'm going to shut the camera off. I'm going to do that and I'll be right back. Okay, so that took about 2-3 minutes. Everything's hot, so be careful now. We're going to flip the table over, and I'm going to show you how we weld the top to the skeleton underneath, okay, in a way that keeps the table from warping. I'm going to flip this over, and I'll be right back. Okay, so I've got the table flipped over, and now we're going to start welding. Now, what we do up here, the first thing I'm going to do, some of the slots are covered by the clamps, but many of them aren't, okay? So every single one that I can get at, I'm going to spray a tack into, okay? Now the goal here, and you'll see this, I'll show you a close-up, the slots are cut out in the middle. And the idea is to put the weld down in that slot, and only down in that slot, okay? It means you don't have to grind that much when you're all done, and by keeping the weld in the middle of the thickness of the table, it's not tending to pull towards the top, it's not tending to pull towards the bottom. So the tabs are specifically designed to hold the skeleton to the table without putting any weld on the top or the bottom of the table. So I'm going to grab my helmet and I'm going to start and I'm going to put some tack welds. And like I said, all I'm going to do here is try and glue this thing together even further without putting any weld in it. So I'm just going to put tack welds in. One more. Two more. Okay, now I did that in real time just to show you how quickly that goes. I'm gonna grab you a close-up of this, and then I'm gonna shut the camera off and fill all of this up, take the clamps off, and we'll take a look at it. Okay, so we finished welded our table. We welded everything we could with the clamps in place. We sunk all of our welds down inside the slots like I showed you in the picture there. And there's very little that's going to need to be cleaned off the top of this thing. Now, when you do go to grind this off, right, don't use, I don't like hard disc grinders. They're great for cutting and back gouging, but for this type of work, I'm going to use some kind of a soft pad. I don't have one laying nearby, but you know what I'm saying? And keep your grinder flat, right? Don't get up there and start digging gouges in it. This one has very, very little. that would actually need to be ground off, and I could probably hit it with a Scotch-Brite pad and call it good. But we usually take and, give it a once over, and that gets all the spatter off of it. I did let this one cool, and we checked it, and this one wound up extremely flat. It's flat to about 11 thousandths. So when we put these together for customers that really, really want flat, we clamp them to a Blanchard ground piece of 2-inch, but you can see I built this just like you're going to build yours, and it's about 11 thousandths is the worst case. In the next video, we're going to put the leg kit together, and we're going to put that on. But this is pretty cool, because at this stage you've built yourself a tool that if you take care of it, you can literally pass down to your children, your grandchildren, and all that. And I don't mean to get sentimental, but I kind of get that way about tools, especially tools that I built myself. So I'm Dave from Tab and Slot. In the next video, we'll put the leg kit together, and then you're going to have yourself a weld table. Have a great day.